Hi, hello everyone. Welcome back to my channel. So today we are going to start a new lesson. So that is shear force and bending moment. So far we completed simple stresses and strain in first lesson. So in that we completed simple problems and simple formula we know such as stress, strain and Young's modulus. So and related problems we solved in first lesson. And next we completed the bars with cross section varies in steps, or that means different diameters. If the different diameters is there, what is the extension, what is the load, we find it in that problems. Next, so far we completed temperature stresses. So in that we solved numerical problems. And next, temperature stresses in compound bars, this is another topic in that. And problems we completed in first lesson. So first lesson simple stress and strain. So now we are entering into the second lesson, that is shear force and bending moment. So in that there is a some definitions and formulas and some notations are used here. So first of all we want to learn the theory of this shear force and bending moment. Afterwards we want to enter the numerical problems. So here we shear force and bending moment diagrams we want to draw. So if the now consider this is a one element or bar. So if we add a load on it, so at that time what is the shear force? For that we want to draw the shear force diagram. So for that only bending moment. So bending moment is force into distance or displacement. So at that time we want to draw the diagram how it is. So we will study in next class. So now we are going to the what are the signs we are using. So which type, which, when, where we use the positive and negative. So these are the importance, which, where, when, how it will be used here. So next, now consider here shear force. So for shear force, so now see, when a body is subjected to right side portion, it coming load coming from top to bottom at that time, and in left side portion at a time, so downward to upward portion, at that time we use a positive sign for the shear force. So we are going to draw the shear force diagrams. So this is a how to draw a shear force diagram. So for that we want to draw the shear force diagram as well as bending moment diagrams we want to draw. See now, see right side portion, that means above the x portion is a middle section. So if this right position, the load is coming from top to the point, so this is point load, at that time it indicates the positive shear force. That is the here what I said here. So when the right side portion, consider section xx is a section plane, so which divides. So in right side position it will act from top to downside, means it indicate positive. Next, bottom to upside means it also is positive in shear force. So now coming to the when a see left side portion only, left side portion, so load coming from top to bottom, and right side portion coming from bottom to top, just opposite to the positive, so this is a negative. So left portion which is coming from top to bottom, it next that indicates it is a negative shear force. Understood? So next right side is a from bottom to the top side, so that is a if the loads acting on the element or bar, at that time we want to use these notations. So this is a understanding process. Whenever we find this type of actions in question, we want to suddenly knows the what is the shear positive, whether it is positive or negative, we want to know, we want to say at that time. See here, shear force is positive when it tended to move left portion upward. See now left portion which is tended to move upward, and right portion moves downward. So at that time we want to indicate the positive sign for the. So it is why I am saying here, this means while solving the problems we want to understand, so which type of loads acting, in what direction it is acting. So at that time according to that we want to take a positive or negative. So next, shear force is negative when it is negative when it tend to move the left portion, so left portion downward and right portion moves upward, at that time we want to take a negative shear force. So this is a shear force. Next, coming to the bending moment. So bending moment is nothing but force into distance or displacement, we can say. So if a load act on this body means, so now if a load act on this body, it will be displaced some distance. So at that time, it's how it moves. So if it moves clockwise or anti-clockwise, so force that means load acted means it will move clockwise or anti-clockwise. So now see, if the body of the right side portion will move anti-clockwise, and at a time the left side moves clockwise, so both at a time it will done means that is a positive bending movement. So when the load act on this body means it at the time the body will tend to move anti-clockwise at the right side, and left side is clockwise, then it is a positive. So and also we can say the sagging effect. This is a when the sagging effect is done by a body, then it is called a bending movement is positive. So sagging effect is very important here, or else it is in convex shape. See how it is in the form of convex shape. Next, when a body tends to move in right side, one is clockwise and left side is anti-clockwise, just opposite to the positive bending moment. So this is a concave, so we can call it is a sacking effect or concave effect. So when the body is moves in right one is clockwise and left side is anti-clockwise, so this can be understand so while solving a problems. So see, the bending moment is positive when it tries to sagging, or the bending moment will be positive, that is if resultant movement is clockwise on the left side. So left side is clockwise and anti-clockwise in right side means then it is a positive bending moment. So this like this opposite, see the positions how it is moving. So see the how it is moving. So according to that we want to find the whether it is positive or negative, identify. After that, types of loads. So we are deriving derivations for that. Now consider this is a cantilever beam. For that, what type of loads acts on this? So we have three types of loads, only three types. One is point load, and uniform distributed load, and uniform varying load. So for that we want to derive the some equations. According to that we want to find the diagrams. So that is shear force diagram and bending moment diagrams. And we have different types of beams. For a cantilever beam, how it means, cantilever means one end is fixed and another one is free end. This is cantilever beam. Next, simply supported beams. That means both ends are simply supported. See how it is. Next, overhanging means, that means overhanging means thus at the supports beyond it will go length. See how it is. So there is a two supports A and B. The length is beyond the A and B. So that is overhanging. So next, continuous beam. That means supports are continue. For that it is a continuous beam. Next, fixed beam. Fixed means both ends are fixed. So that is a fixed beam. So mostly we use cantilever beam and simply supported beams, and sometimes only overhanging beams. Other than that we don't need continuous and fixed beam, we don't bother about that. So only concentrate on cantilever beam and simply supported beam, and when compared to that it is very low only, that means its weightage is low. So don't bother about this also, only concentrate on two. So next class we will discuss and directly we can conclude it. So thank you for watching this video, and continue the next video. So then you can know the, or you can understand the how to solve the problems of shear force and bending moment diagrams. Thank you.